Welcome to All This Math. This is Professor Parker, and today we're going to talk about mural arts and scale. Okay? So we have some information behind us about a mural that is going to be drawn, or a mural that's going to be painted or placed up on a wall somewhere. And this is some background information. So first we want to read the information and understand what the information is telling us. And then after we do that, then we're going to attempt to figure out the answer to the question that is presented. So first, you see the first bullet point says there's a picture of George Washington Carver, right? Very well known, very important scientist, of the early 20th century, who did a lot of work at Tuskegee University, a lot of good work. And on this picture, someone is drawing like a picture of George Washington Carver and also Tuskegee University, right? Since that's where he was a professor and that's where he taught, right? And that's also where he went out into the surrounding area in the community and taught the local people that weren't able to gain admission to Tuskegee University for whatever reason. He still taught them science. So really, the people that couldn't come to the college, he actually brought the college to the people. So we have George Washington Carver and Tuskegee University on a picture, on a piece of paper, on a regular piece of paper. Right? On this regular piece of paper, the picture is 5 inches wide and 2 inches tall. These are the dimensions of the picture. 5 inches wide, I don't know, that might be about 5 inches, and 2 inches tall. So that's kind of small, right? Maybe 2 inches, I'm not sure, right? But 5 inches wide and 2 inches tall. Now, somebody wants to draw a mural or paint a mural on a huge wall, right? The mural is going to be on a 20-foot wide wall. Now, the wall is 20 feet wide, right? And then our question is, how tall will the mural need to be in order to, and part of the question is actually left off. How tall will the mural need to be in order for the picture to remain at scale? Now, what does scale mean? Scale means that when you take a small version of something and you expand it out into a larger version, the dimensions are in the same relationship to each other, right? So meaning if it got wider, right, it got taller at the same rate that it got wider. So it doesn't look weird, because if it's not to scale or it's not proportional, then when you stretch it out, which is what's going to happen, the picture is going to look weird, right? Because here you're taking something that's 5 inches wide and you're going to make it 20 feet wide, right? So it's going to get a lot bigger. Now, the question for us is, if we make it 20 feet wide, what do we have to do with this 2 inches? How much bigger is that 2 inches going to be? How much taller is that 2 inches going to be? All right. And now we're going to do the math to show how to do that, how to answer that question. So the first thing we need to do is figure out something called our scale factor. That's the first thing we need to do. Figure out something called the scale factor. Scale factor. Now, the scale factor tells us like how the dimensions of the small version relate to the dimensions of the big version. So how the dimensions of the picture on the paper, how do they relate to the dimensions of the actual mural that's going to be painted, right? Now, how do we figure out the scale factor? What we can do is we can say, okay, well, I know how wide it is on paper, and I also know how wide it will be on the wall. So I can show a relationship between those two dimensions. And we use a fraction for that. We use a fraction. A fraction, the number that's broken into two parts. It has a numerator on top and a denominator on the bottom. So I can do this. I can say, okay, scale factor, 5 inches is going to be equivalent to 20 feet. 5 inches is equivalent to 20 feet. But when I deal with a scale factor, I need for one of these numbers to be a 1, right? I need for one of these numbers to be a 1. Usually it's going to be the smaller number. And out of 20 and 5, 5 is the smaller number. So really what I have to do is reduce this fraction. So I got 5 over 20. Now, how do you reduce fractions? You reduce fractions by thinking of or finding a common factor, right? If there is one. In this case, there is a common factor between 5 and 20. there's a number that divides evenly into both 5 and into 20. That number is 5. So what I do is I divide 5 by 5 and I get 1. And then I divide 20 by 5 and I get 4. So this becomes 1 inch over 4 feet. So what that basically means is every inch, in terms of this drawing, every inch on paper is equal to 4 feet on the wall. Think about that. Every inch on paper is equal to 4 feet on the wall. So that's how we know how this picture that's on paper has to be stretched out when the mural is actually drawn on the wall, right? So that everything is still in a proportion, what's called a proportional relationship, right? Because we don't want to distort and mess the original picture up. Because what we're trying to do is we want to take that same picture that's on paper and just blow it up and just expand it. But we want to expand it vertically and we want to expand it horizontally, but at the same rate. Because if we don't do it at the same rate, like I said earlier, the mural is going to look weird and it's not going to look like how it was on the original piece of paper. So now, what I want to know is how tall would a mural be, right? Now, I know how tall the picture is, but I don't know how tall the mural is going to be. So I'm going to take this fraction right here, and I'm going to say 1/4, right? Because that's my scale factor. 1/4 is my scale factor, okay? Because every inch is equal to 4 feet. So 1 out of 4, right? And then I'm going to create what's called a proportion. A proportion is when you have two fractions equal to each other. So I got this first fraction, 1/4, is equal to the height, right? I need a fraction that represents the height. I have one fraction that represents the width, right? This 1/4, but I need a fraction that represents the height, how tall it is. So in my numerator, I have the height, or the width actually, of the picture. So that means in my numerator over here, I should have a dimension that represents the height of the original picture also. So that means I got 2. And I don't know how tall the mural should be. So for now, I use a variable. So we're going to do a little bit of algebra, right? I use a variable. Because whenever I have something I don't know, a value I don't know, I use a variable. Now, how do I solve for x? This is how you do it. When you're dealing with a proportion, when you have a fraction that's equal to another fraction, you do something called cross multiplying. Cross multiplying, which means you multiply diagonally. So I go this way, boom, 1 times x. 1 times x is x. 1 times x is just x, or 1x. 1x is simplified to just plain x. So I write x right here, and then I bring my equal sign down. And now I need to cross multiply in the other direction also. And I do 4 times 2, because I'm cross multiplying, meaning I'm going in the x direction, right? Both directions, this diagonal, that diagonal. And 4 times 2 is 8. Now what this tells me is that this mural, if it's going to be kept at the same scale as the original picture that was drawn on a piece of paper is, then just as this 5-inch picture is stretched out to 20 feet wide on the wall, this the 2 inches from the picture needs to be stretched up to 8 feet tall. That's our answer right there. How tall would a mural need to be in order to be in scale, or be to scale rather? It needs to be 8 feet tall. And that's about it. And when you see a question like this, that's how you do it. You figure out your scale factor, and then you create a proportion, and then you solve for the unknown value. And that's pretty much it. And I like problems like this because problems like this relate to real life, real life experiences and things that we see. Like we ride around, no matter what city you live in, we see murals, right? And you may wonder, well, like, wow, like how did they know how large to make that mural, or how did they know how large to make his face, or how large to make his body or her face, or whatever, or if it's a building, how did they know? Like, how did they know the proportions and the scales? They used some mathematics. That's what they did. All right. Hope you learned something. Please subscribe to the page if you haven't already. Like the video, share the video, tell some other people about it. And as always, remember, there's all this math all around you. Peace.